on page 23, we are going to talk about systems of equations. You guys saw systems of equations in Algebra 1. If you were in Algebra 1 right now, that's what you would be working on. We're studying for a quiz right now in Algebra 1 over solving systems of equations. So the methods that we're going to talk about should be familiar. The difference is that instead of using only linear equations, we're going to see quadratic equations in the mix for our systems. So in Algebra 1, that's the difference. In Algebra 1, it was 2 linear equations. In Algebra 2, we're going to see maybe a linear equation, a quadratic equation, maybe 2 quadratic equations, but we're sort of stepping it up in that way. So we're going to talk about 3 methods for solving a system of equations, the same 3 you looked at in Algebra 1. So we're going to use graphing as an option. So we will need our calculators for today. We'll also use the substitution method. And we'll also use the elimination method. And all of these you saw in Algebra 1. So we're going to start with our graphing method. When we learned these in Algebra 1, we did them in this order: graphing, substitution, elimination. So that's the way we're going to approach them here. So we're going to use our calculators to graph these systems, especially since we're dealing with things that might be parabolas that aren't centered at a nice place, or they don't have nice coordinates for their vertex or their stretch. So some of maybe their other points aren't super nice, and we're intersecting them with lines or maybe other parabolas. We're going to graph these on our calculator rather than on a coordinate plane. So the solutions when we're graphing are going to be the intersection points. Maybe points plural. Where those 2 graphs meet, where those 2 graphs intersect. This is the same idea as when we were solving linear functions by graphing. So on my calculator, I'm going to add a graph. You could do this on Scratchpad if you wanted to. And for that first example, I have y equals x squared plus 3 minus 7. As a reminder, when your function is y equals, you don't need to type in the y equals. That's what the f of x part is for. So you're just typing the other stuff. So we have x squared plus 3x minus 7 as our first function. And I'm going to hit enter. And then I'm going to hit the tab key to bring up that entry line again. And my other function is y equals 3x minus 1, so 3x minus 1. Now I've got both of my functions graphed on the same coordinate plane. I'm just going to scoot these over a little bit. And what I'm looking for are the intersection points. So I can see that I've got an intersection point right up here, it looks like. And then we should also be able to anticipate another intersection point down here somewhere. So I'm going to zoom out just a little bit. And then I know I told you guys earlier, I usually like zoom fit, but since we're so close to seeing what we want, I'm just going to zoom out. There we go. And I can see that other intersection point and this one as well. Hit the escape key to get rid of my zoom function. And now to find those intersection points, I'm going to hit menu, go down to analyze graph, and select intersection. And then just like we have to find our zeros, to find minimums and maximums, when we were solving using a graph and we were looking for the intersection between the 2 halves of our function, we use the same feature, so it works exactly the same way. I'm going to click on either side of this first intersection point. Remember, you're clicking on either side, not trying to land on it. So when I click on either side, there's my point. My calculator may be showing more decimals than yours is. That's okay. We'll round to 2 decimal places here in just a second. And then I need to find the other one. Menu, analyze graph, intersection. Again, we have to find them separately. So I'm going to click once to the left and once to the right. When you're clicking to the left, remember that you need to be outside of that first intersection point you saw. So you're trying to land somewhere between the 2. Otherwise, you're just going to pick up that same first point again. And there's my other point of intersection. Let me scoot this so we can see those numbers. Okay, so now I'm going to round to 2 decimal places and jot those points down. Now, where this is going to be a little bit different is I'm going to give that entire ordered pair. We're talking about a system of equations, just like in Algebra 1, when we solved a system of equations, my solution was the entire ordered pair. That's the same thing here, okay? If I'm solving a quadratic equation, that's only the x value. When I'm solving a system, that's x comma y. So I graphed this on my calculator, and I found those intersection points to be, and around to 2 decimal places, negative 2.45, comma, negative 8.35, and then positive 2.45, comma, 6.35. Questions for me so far? When we solved using graphing in Algebra 1, we had lines that we could graph, and so for the first few problems at least, I gave you a coordinate plane and asked you to sketch the graph and locate that intersection point, graphing by hand. We did also look at some problems where you graph using your calculator. Since we've got sort of more complex, higher degree functions here, if I ask you to solve by graphing, we're typically going to be graphing on our calculator. The next method that we're going to look at is substitution. So the idea behind solving a system using substitution is that I want one of these equations to be solved for a variable, and then I plug whatever it's equal to into its spot in the other equation. Okay, I substitute it in, that's why it's called substitution. So for this first equation, this first system, I should say, the second equation that I have is already solved for y. I already have y by itself. So I can go ahead and plug this in to y in my top equation. So I have x squared plus, instead of y, I've got x plus 1 squared equals 13. I've only replaced y. It had a squared on it, that still applies here. If it was 3y, there'd be a 3 in front of it. The only thing I'm swapping out is the y. And then I need to distribute this. Remember, when I have a quantity squared, that means that thing times that thing. So I have x squared plus x plus 1 times x plus 1 equals 13. So now I want to distribute here. That gives me x squared plus 1x plus 1x plus 1. And I'll combine my like terms. So I have 2x squared plus 2x plus 1 equals 13. From here, I can solve using any of my quadratic methods that I want to. But all of our quadratic methods that we've talked about, with the exception of square roots, and this one I can't solve with square roots because I have x squared and x, but all of my other quadratic methods, we've needed standard form. We put everything on the same side. So that's going to be my first step here. I'm going to move the 13 over. So I have 2x squared plus 2x minus 12 equals 0. And then I'm going to pull out a GCF here. I can divide each of these evenly by 2. So I'm going to go ahead and do that. And from here, if you wanted to complete the square, you could divide the 2 to the other side and complete the square. I wouldn't choose to do that here because your b value is 1. So you're going to get fractions, which is probably not our best option. If you wanted to divide the 2 to the other side and use quadratic formula, you could. I will say from your quizzes last week, quadratic formula was not a bad option, but an option where a lot of us made like little computational errors. But this thing factors nicely, so I'm gonna have to factor this. Factors of -6 that would add to 1 would be 3 and -2. So this would be 2 times x plus 3 times x minus 2. Set each factor with an x equal to 0, and I would get x equals 3 and x equals -3 and x equals 2. Now in Algebra 1, when we solved, we got one value for x or y, and then we plug that back into one of our original equations to solve for the other. Here we've got two values for x, so what we're going to do is plug both of them back into one of our equations. I strongly encourage you to plug into whichever is going to be your simpler equation, whichever is going to be less work. So I'm going to plug in here. So this would be when x is -3, I would have y equals -3 plus 1. And then when x is 2, I would have y equals 2 plus 1. So I get y equals -2 and y equals 3. Now I'm going to write ordered pairs with my solutions. So one solution would be -3, -2. The other solution would be 2, 3. Questions for me so far on that substitution method? Okay, we have one more strategy or solving method that we're going to look at for today, and that's elimination. So if you turn the page for me, we're going to look at a problem with elimination. The idea behind elimination is that we're able to add our equations together, and when that happens, one of our variables has the same coefficient but opposite signs. So 2x and -2x, or 5y and -5y, so that when I add them together, one of my variables eliminates from the problem. I've got no x's left, or I've got no y's left. Looking at my first example on the top of page 24, these equations are already set up for my y's to eliminate. I've got plus y squared and minus y squared here. And notice that's my only y term in either equation is that y squared. So I, right off the bat, can go ahead and add these equations together to eliminate a variable. Now, if I didn't have that already, one thing I would look at is, are there multiple x's or multiple y's? In the top equation, I've got x squared and x. I don't have an x term in the bottom that I could eliminate this x with. So if I chose to eliminate the x squared, I would still have y squared and x, and that's not helpful. I need only x's or only y's. Okay, so even if these weren't already set up to eliminate nicely, I would want to choose to eliminate the y squared because they're the only y terms. So I'm going to go ahead and add my equations together. When I add the x squareds, I get 2x squared. My y's, y squared minus y squared, are gone. They eliminate from the problem. I would have no y squared left. And then I'm going to go ahead and write this in standard form as I finish simplifying. Here's my only x term. I don't have an x term down here, so this would be minus 16x. And then 39 plus -9 would be 30, equals, on the other side, 0 plus 0 is 0. So we only have x's now. I'm going to start, since we've got standard form, by factoring out my GCF of 2. So that would give me x squared minus 8x plus 15 equals 0. And then if you want to divide the 2 to the other side and complete the square or use quadratic formula, you can, but this is another function that factors nicely, and that's probably going to be our easiest option. So this would be factors of 15 that add to -8 would be minus 5 and minus 3. So I get 2 times x minus 5 times x minus 3. Set each factor with an x equal to 0 and solve for x. So we get x to be 5 and 3. And then just like we did with our substitution method, I'm going to take my x values and plug them into one of my original equations to solve for y. I'm going to choose to plug into the bottom equation here. If I plugged into the top, I would have to plug x into 2 different places. So I'm just going to opt to plug them into the bottom, so I only have to plug them into one spot. So when x equals 5, this would look like 5 squared minus y squared minus 9 equals 0. So I have 25 minus y squared minus 9 equals 0. I'm going to combine my like terms here. 25 minus 9 is 16. So I get 16 minus y squared equals 0. I need only the y squared on this side. I'm actually, since it's negative, going to go ahead and add the y squared to the other side. Otherwise, I'd have to divide by -1 later. And now, since I just have a squared thing, I can solve this using a square root. Square root of both sides. So I get y equals plus or minus 4. So from this one x value, I actually have two solutions. I have 5 comma positive 4 and 5 comma negative 4. Two y values here that match the same x, so I need to give those two ordered pairs. And now I'm going to plug in x equals 3. Again, I'm going to plug into that bottom equation. So I get 3 squared minus y squared minus 9 equals 0. 3 squared is 9 minus y squared minus 9 equals 0. I'm going to combine my like terms here. 9 minus 9 is 0, so I'm just left with negative y squared equals 0. Since I have negative y squared, I need to divide both sides by -1, so I have just plain old y squared. And then I can take a square root. So I get y equals, the square root of 0 is just 0. We don't need plus or minus on 0. So I just have y equals 0 there. And I only get one solution when x equals 3. It would be 3 comma 0. There are my 3 solutions to that system. Questions for me on our elimination method? Okay, so we did one example together of each solving strategy. We did a graphing problem, we did a substitution problem, we did an elimination problem. You'll notice that there was one more problem for each of those methods. Your homework for tonight is to go through, there's a notes video posted on Delta Math to sort of walk you through that second example of each of these. But your homework for tonight is to go through that second example of each of these to practice solving by graphing, solving with substitution, and solving with elimination, okay? So the leftover examples on pages 23 and 24 with that notes video on Delta Math is your homework for tonight.